First, I draw axes with the numbers from left to right and letters from top to bottom in the place where the columns will come with the grid command. In the column command, I selected and added a reinforced concrete column from the structural column section of the metric library VS part in Revit and adjusted the dimension of the added column to be 30 cm according to my own project. I selected all the grids with the grid at grids command, and thus columns were added to the intersection of the grids. In the beam command, I selected and added a reinforced concrete beam from the structural framing section of the metric library VS part in Revit and adjusted the dimension of the added beam to be 30 cm according to my own project. I selected all the grids with the onGrids command, and thus beams were added between columns in the direction of the axis. I separated the structural system from the building. I created the floors with big walls in the floor command. I added a new level for the foundation in elevation and copied the system. I created a lower level. I transferred the Revit model to Grasshopper using the Rhino Inside Revit plugin. The built-in categories command allowed me to access the categories in Revit, and the incoming data was classified with the category filter. For example, I used structural columns to select only column elements. I extract the geometry information, line or curve, of the selected elements with the element curve or element geometry command. I converted these lines representing the structural order into analyzable column and beam elements with the Caramba component line to beam command. Then I defined the concrete C3037 material with the Caramba material component. I used the trapezoidal section option of the cross-section command to assign a specific section from the beams and columns, and I entered values such as section width and height as parameters. I converted the slab geometries into mesh with the mesh prep component in Grasshopper. Then I defined them as shell elements in the Caramba. These commands allowed me to analyze the behavior of the slabs under loading conditions. With the support conditions command, I defined fixed support conditions for the column bases and provided movement restrictions in the X, Y, and Z directions. With the gravity command, I ensured that the gravity force was applied to the structure. Thus, the loads are distributed equally throughout the structure. With Caramba's analyze command, I calculated the stress and support reaction forces of all elements. Finally, I visualized the analysis result with Caramba's model view command. In particular, I showed the results such as displacement in beams, stresses in slabs, and support reactions in different colors.